laugh out of it. So what happens here is that you've got this generic standard form of a quadratic. And you guys have all seen that before. ax squared plus bx plus c. The values of a, b, and c have specific meanings to them. And we'll get into how that works out. If you're going to graph something in standard form, which you guys have done in the past, do we all remember that every quadratic looks like a parabola? Do you remember what a parabola looks like? It's a U. It's either up like a cup or down like a frown. Up like a cup, down like a frown? Down? Okay.
Oh, I don't.
So what happens here, really put this in a separate, I'll come back to the other forms, is when you're dealing with a quadratic, every one of these is up like a cup or down like a frown. They're either real narrow or real wide. It all depends upon some of the other values in the problem. Now, the one way to know whether or not it's up like a cup or down like a frown is by what do you think? A. If A is positive, it's up like a cup. And if A is negative, it's down like a frown. That's a real obvious way of remembering it. The other thing to talk about when you're looking at parabolas is that, do you remember about this crazy little thing called the axis of symmetry? Yes or no here? Do you guys know what that means? What does it mean to be symmetrical? Yeah. So what happens here with a parabola, there's what you call an axis of symmetry. And that axis of symmetry in every single parabola is a vertical line that goes through the vertex of it. So it's folded upon itself in either way, whether it's up or it's folding downward. Now, what we do to graph these things is that we always want to first figure out what your axis of symmetry is. And this is a very easy formula to do. Your axis of symmetry, like I said, is always going to be a vertical line. What does every vertical line start with? X equals, good. So your axis of symmetry, here it is.
DeKalb High School. We are now going to conduct our intruder drill. Once again.
If you guys got other questions about that drill stuff, just talk with me later. I'm pretty honest about my feelings about how things work and how things should work. I'll be more than happy to let you know what I'm thinking. Remember, when I talk about this axis of symmetry, every parabola has an axis of symmetry that's always x equals some number. And when you're dealing with it in this standard form, it's always going to look like this. X equals the opposite of the b value divided by 2a. And that allows you to calculate what the axis of symmetry is. That's going to give you some numerical value. For example, if we take a standard form equation of a quadratic, y equals, 3x squared minus 4x plus 6. I have no idea if it's factorable or whatever. All I'm doing is just looking at that equation. If I wanted to figure out what the axis of symmetry would be, all I would do is my b value here is negative 4. Okay? You keep the sign that's in front of it and then the value. So my axis of symmetry would be x equals 4, because it's the opposite of negative 4, divided by 2 times 3. 4 over 6 is 2/3.
Wait, why is it a positive 4?
It's the opposite of b. So b here is a negative 4, so the opposite. Negative 4 is positive 4. Okay. They write it as negative b, but I always say it as opposite of b. I think it's just cleaner to say. Okay. So your axis of symmetry would be through x equals 2/3. Is that the world's worst? I'm gonna break my ruler. Is that the world's worst thing to kind of graph? Somewhere between 1 and 2, could you just draw a dotted line, a vertical dotted line? That's kind of what you're looking at. So when you're graphing these style questions that deal with things in standard form, like I said, the first thing that we're going to do is, we'll use this as our example, standard form. First thing is get axis of symmetry. So I have y equals 2x squared minus 8x plus 6. I'm going to get my axis of symmetry. X is going to equal, well, I've got the opposite of negative 8, so it's 8 over 2 times 2, otherwise known as, all right, so it's 8 divided by 4. So we now have a vertical line that goes through x equals 2. When you draw your axis of symmetry, it's not a line that's really there. So how do you draw a line that's really not there? Dotted. Very good. You just draw it as a dotted line. So what you do is you draw a dotted line through x equals 2. Okay? I know my parabola is going to be wrapped around that vertical line. One other thing that we also now know is whether or not this is going to open up or it's going to open down. Is this going to open up or down? It's going to open up. Why is it going to open up again? Because it's positive. I know it's going to open up. Now here's the next question. Let's see if you remember this. Does that mean this point is a minimum or a maximum? A minimum. It's a minimum. Good. So when it opens up like a cup, that point is a minimum. Now, what else is that point called? Vertex. Very good. It's a vertex. So the second thing you're going to do is after you identify where your axis of symmetry is, you're going to figure out what your vertex is. Well, that's really, really easy to do because you already know what the x-coordinate is for your vertex. Since your vertex lies on that axis of symmetry, that means that's the x value for the vertex. How do you figure out the y value is? You just substitute it in. What's 2 squared? 4. What's 2 times 4? What's 8 times 2? What's your y value? Negative 2. So your vertex is at negative 2. We know it's got to open upward, so now what you do is you plot a couple of what are called symmetric twins. Here's what I mean by that. What if x is equal to 0? What's your value for y?
0.
Look again. 6. If x is equal to 0, 0 minus 0 plus 6 is 6. Do you agree? So that means at 0, it's 6. How many spots away from that axis of symmetry is 0? Is it on the left or the right of the axis of symmetry? So that means 2 spots to the right of it should also be at 6. See what I'm doing there? I'm picking a very easy number to substitute in to get a pair of what are called symmetric twins. Symmetric twins mean nothing more than these are equidistant to the axis of symmetry. Parabolas all have that. Another set would just use 1. What's 1 squared? What's 2 times 1? What's 2 minus 8? What's negative 6 plus 6?
0.
So what we've done here, since this is 1 over from it, the other one's got to be 1 to the left of it. Does that make sense? You guys vaguely remember this?
Yeah.
We've now plotted 2 sets of symmetric twins. It's kind of like the generic way if I want to do it. Connect the dots, la 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 la. And there's your graph. Like I've said, it's nothing too fancy, nothing too crazy, especially when you're working from standard form. It's the other 2 forms that are going to be a little bit newer for you. If you recall when we talked about lines, I hit you in absolute value. Remember when I hit you guys to the A, H, and K? Guess what we have now? A, H, and K. What do you think the H and K are going to represent when you're dealing with these? X and Y. What did the H do earlier? It moved it somehow. How did it move it? How did it move? H goes with what? X. What other word in math starts with H? Okay. Horizontal. Remember? Horizontal left and right. Vertical up and down. H moves it left and right. K moves it up and down. So let's. You don't remember that?
Well, I know wherever you're saying that.
Vertical. H and K, horizontal H, vertical up and down? Yes, I did.
Yeah, you did, yeah.
You probably did.
You guys all have peanut butter in your ears. Here's oh, that's a good old Smokey the Bandit line. What do you got in your ears? Peanut butter or something? Anyway, you have two new forms. It's called vertex form and intercept form. Vertex form deals with what are called A, H's, and K's again. We'll deal with this one first. Then we'll come back to the other one. When I'm dealing with something that's written in vertex form, you get y equals a times the quantity x minus h squared plus k. Now, that means that your vertex is going to lie at h and k, and the axis of symmetry is at where x equals h. To tell whether or not this opens upward or downward, what do you think we have to pay attention to? A. If A is positive, and A is negative. Very good. So if I have something very simple as y equals 1/2 x plus 3 quantity squared minus 4. Do you remember the tricks that we had to do to identify the h's and the k's? Think about absolute value. My h and k here, in the parentheses it says x plus 3. In the generic form it says x minus h. What's my value of h?
-3.
Good. My h value here is -3, and the k value always stays the same. Remember, when you're working with the h values with these, anytime you have a, h, and k, anytime that's a, h, and k, the h value is always the opposite of what it's showing, no matter what we do. When we do these, work with these things in radicals, we work with them in exponentials, logarithmic, all those, trigonometric, every single one of those things. Any value of h is always the opposite number. K value always stays the same. So my k value here is at -4. Now, this tells you where your vertex is. So when I go to plot something like this, let's get a small graph here. Oops, lost it. When I go to plot this, I know that my vertex lies at -4, or excuse me, -3, -4. I know that the axis of symmetry is also at that x value. Remember, your axis of symmetry is always the x coordinate for your vertex. I know it's going to be opening upward. And then it's just a matter of picking some easy points to work with. Okay? And I happen to pick something with a 1/2 in front of it. Now, in your crazy calculator, is there a button that says y equals? Is there also a button down there that says table? Could you get a table set of symmetric twins rather easily? Do you guys remember how to do that? All right, let's take a look at it real quick. There we go. Go to your y equals button, top left, and you want to type in the equation 1/2 times the quantity x plus 3 squared minus 4. This is the slowest thing in the world to load. It's not dial-up connection. It's right there in the. It's down the computer. Yeah, type in the equation. It was y equals. I'm just going to use 0.5 because it's quicker to type. Parentheses x plus 3 quantity squared minus 4. Go to your table.
17
Yeah, well, come on. I made this equation up off the top of my head. I just wanted to show you guys how you can get symmetric twins. We all know that your axis of symmetry occurred at what? X equals -3. If you scroll up and down on your table, you'll see that in here you're going to, if you put your axis of symmetry kind of in the middle, does everybody see, let me put this on the big screen. Do you guys see how the axis of symmetry is at -3, -4, and then as each pair going outward, it's changing it? They're the same. At 0, it's 0.5. -6, it's 0.5. At -1, it's -2. At -5, it's -2. It's creating those symmetric twins since these guys are all equidistant from that axis of symmetry. So all you have to do is be able to go to your table values and plot two sets of twins. Okay? At -1, it's -2, which means at -5, it's -2. At 0, it's a little more than half. And there's my graph. That's it. Okay? That's what we call, what is this called again? Vertex form. I forgot. Wasn't sure if I was at that one or the next one. All right? A, H, and K. It's just a matter of going through the year. You plot the vertex, takes that axis of symmetry, use your calculator, table set of values, bada bing, bada boom. One more form. I know you're waiting with bated breath. It's called intercept form. Intercept form looks a little bit different. You have y equals a times the quantity x minus p times the quantity x minus q. What they're doing here now is they're writing it out as a factored form of the standard equation. That's nothing more than a standard equation factored. What are your terms? Okay. What this allows you to do is find your zeros. If you guys recall, when you did stuff like this, you were able to plot zeros and find zeros. The axis of symmetry always occurs at the midpoint of P and Q. And I'll explain to you guys what this looks like here. So once again, if I have an equation, y equals -2, x minus 4, x plus 2. What you're looking at doing here is identifying what the zeros are. Now, we haven't really discussed what zeros are yet in this chapter, but you guys remember what that meant? What does a zero mean? It's the intercept. It's where it's crossing the x-axis. In order to figure out what your zero is for these things, is you set these terms equal to 0. Remember when you did that when you were factoring? When you had a factored equation that said equals 0, and you had to figure out where it was crossing the x-axis? That's what we're doing here. In order to figure out your zeros here, well, it's x minus 4 equals 0, or x plus 2 equals 0. What's my 0 here? 4 and -2. So once again, notice x minus p. Well, x minus 4, so my value of my intercept is 4. X plus 2, my value of my intercept is -2. So when I go to plot that, that means that this graph crosses the x-axis at 4 and -2. Does it open upward or downward? Downward. So is the vertex going to be a maximum or a minimum?
A maximum.
Good. See, I haven't even, you guys remember this stuff. So once again, if I'm looking at one like this, I know my zeros are occurring at 4 and -2. I know that it's opening downward, and my axis of symmetry occurs at the midpoint. Well, how far apart are these guys? So what's the halfway point then? Well, 1, 2, at 1. So my axis of symmetry is the halfway point between the two. Everybody see how we did that? All we did was figure out how far apart they were, cut it in half, and just walked it. It's the easiest way to do it. Or you can add them together and divide by 2. It's the average. That way it works as well. So I know that my axis of symmetry occurs at x equal 1. Now what do you think you have to do to find the vertex? Substitute in, exactly. Since your axis of symmetry is at x equals 1, that means my vertex is going to be at 1 comma something. So we go to the main equation. What's 1 minus 4? What's 1 plus 2? So what's negative 2 times negative 3? And then what's 6 times 3? So it's up here. How about this? I'm going to go by 2's here, so it's going to be here. I'll call that 20 and call this 10. Is that okay to change the scale up a little bit? Remember, I picked these numbers randomly just on the fly just to show you guys different values of A. So whenever you're trying to find your vertex, what you're doing here is you're just substituting in what your axis symmetry is for the x value, and that allows you to find that. Now from there we know it's falling downward because that's the maximum value, and go from there. Could you hit the table set of values again with your calculator, find another set of symmetric twins? And that's about the bare minimum of what I'd ask you to be able to do. Yeah, that's what we're starting with today. What I want you guys to be able to do with these problems is, I'm going to give you 6 graphs, 2 of each type. The 6 graphs for tonight, I want you to identify your axis of symmetry, the vertex. Is it up like a cup or down like a frown? So if this up like a cup, what's the vertex? Is that a maximum or a minimum? Make sure you start writing that down. It's very important because I'm going to show you a nice little trick with maximum and minimums. So let's just do that for today. We're not going to worry about the algebra of moving back and forth between the two. So we'll worry about that stuff tomorrow. Oh, what is this? Page 253. We'll do those 6. You should all have one more sheet of graph paper, right?
Yeah.
So you need more in the back. We'll do those 6 problems. It's 2 from each style. Graph them. Axis symmetry, vertex, is it a maximum or a minimum? And 2 sets, forgot about this, symmetric twins. All right, just to get you in the habit of that. If you use your graphing calculator to get your symmetric twins, it's not the end of the world. All right, we'll talk about how to switch between the 2 forms tomorrow. Yes, sir. Remember, symmetric twins, if you were looking at, see how this is 2 spots away from here? That's 2 spots away. I want you to apply 4 full points on relative vertex. All right. Questions? Does this vaguely look familiar as far as the start of it? I know some of the other stuff's a little bit newer, but it kind of falls into play there. Okay.